solve the question papers which were uploaded in the classroom. Nusaiba joined late, so obviously she couldn't do that. So what I'm going to do is that we are obviously today going to solve the vectors worksheet. And after that, I'm going to give you guys 2 more worksheets on graphs. Now again, graphs cannot be separately given because graph is a combination for your equations of motions and kinematics, right? So we are going to provide you 2 worksheets for that, and you guys are going to solve that. And I'm going to give you 1 week entire. Okay, so if I'm going to provide the worksheets by tomorrow, that means by next week Wednesday you guys have to submit the worksheets for the entire graphs part. Is that okay?
Yes, ma'am.
Also for Nusaiba, can you please list down your problems that you got from your the previous question papers, like the worksheets we gave already in classroom, and we will do your problem solving again on next week Wednesday. Okay, so by next week Wednesday, submit all the files. I think till now I have 1, 2, 3 question papers already uploaded in the classroom, and including these vectors one, there will be 4. And after this, there will be another 2 to 3 worksheets will be uploaded by tomorrow. So in total, 4, 5, 6, 6 worksheets for you, Nusaiba.
Okay, ma'am.
Okay, and you need to submit the files by next week Tuesday because I need some time to solve your papers, like to check your papers. Okay, for others, they will submit by Wednesday and you will submit by Tuesday. Okay. This is the file. 1 minute. I don't know where
মিস
Aditya.
আমি কি অ্যান্সার লিখে সেন্ড করব?
হ্যাঁ হ্যাঁ, আনসার পেপারটা যদি তুমি সেন্ড করো তাহলে আমার একটু বেটার হয়, কারণ এখানে আনসার পেপারের মধ্যে যে মার্ক স্কিম ওয়ার্ডস গুলো থাকে সেটা তো আমি একটু চেক করলে বেটার হয়। তুমি দেখো
ওকে ম্যাম।
ক্লাসরুমে আপলোডিং এর অপশন আছে, আমি তোমাকে দেখাই।
মিস আমি
তুমি
অ্যান্সারগুলো
হোয়াটসঅ্যাপে তুমি
পিডিএফ
হ্যাঁ হ্যাঁ পিডিএফ করে তারপরে পাঠাও, তাহলে আমার জন্য চেক করা ইজি হয়, কারণ তাহলে এই যে এখানেই তুমি কিন্তু এক্সাম ওয়ানটাও সলভ করবা, কারণ এক্সাম
জি ওটা
ওয়ানটাও
একটু
আমি হচ্ছে কারোই মার্কিং করি না আমি এক্সাম ওয়ানে। এক্সাম ওয়ানটা জাস্ট ওয়ার্কশিটের মতো একটা টাইম ধরে করাইছিলাম, তো ওটাও থাকবে। আর এই যে এই ওয়ার্কশিটস গুলো এখানে এখানে তুমি সাবমিট করতে পারো। আচ্ছা, গ্রাফসের কি আমি কোনো ওয়ার্কশিট দেই নাই? একটা মিনিট প্লিজ। ক্লাস স্লাইডস, কাইনেমেটিক্স, ওয়ার্কশিটস, ইকুয়েশনস অফ মোশনস। ও আচ্ছা, আমি গ্রাফসের কোনো ওয়ার্কশিটই আপলোড দেই নাই। কারণ এটা কি? না, আচ্ছা এর জন্য এসে গ্রাফসে অলরেডি একটা ওয়ার্কশিট আমার কাছে বানানো আছে, সেটা আমি আপলোড দিয়ে দিব আজকে, আর বাকি 2টা বানায় আমি কালকে আপলোড দিব। হ্যাঁ, এন্ড এটা হচ্ছে ভেক্টরস এর ওয়ার্কশিট যাচ্ছে। আমরা আগের ক্লাস পর্যন্ত we completed the vectors, right? We saw the parallelogram theory, the triangle theory, how to draw um, a vector diagram when multiple forces are acting on them, how to find out the components, right? Whenever vector quantity is acting on a particle that is not entirely on the vertical plane or on the horizontal plane, then you have to work with the components. Now again, there's one other thing that we didn't actually taught so far, which is this one, inclined planes. 1 minute. I saw that question. This one, question A16. This is an object that is already situated on an inclined plane, and for these situations, the components will be divided, but the angles you have to find out separately. Okay. I mean, yes, this kind of things we did in M1, but in physics, I haven't taught you this. So we're going to understand the entire concept for this inclined planes and obviously solve the other questions. Okay. So let's start from question 1. We'll solve that inclined plane concept within the class. Okay, we do not need to like একদম পুরো class ওটার জন্য লাগবে না. It's just a very small concept. Achha, so in question 1, we can see that a pendulum is held in stationary by a horizontal force H. The 3 forces acting on the bob are shown in the diagram. Weight is acting vertically downward. Horizontally, there is this force H, যেটার জন্য অবজেক্টে এরকম ভাবে ইকুইলিব্রিয়ামে আসে, and there is this tension acting 30 degree from the vertical plane. আচ্ছা এরকম হলে আমাকে কি কাজ করতে হবে? আমি আগে components বের করব। Obviously, I can understand this h and weight are acting in the vertical and horizontal plane. They will not have any components, but the tension will have components. For that tension, আমাকে একটা vertical plane draw করতে হবে and a horizontal plane. Right, 1 minute. This is your vertical plane and this is your horizontal plane. Now you have to think of this. If you guys remember in again, I think in maths, these are two parallel lines, right? This line and this line is parallel line. If two lines is creating 30 degree, like this tension was creating 30 degree with the vertical plane, over here, it will also create the same 30 degree with the vertical plane according to your alternate angle theory, right? I think there were these certain types of angles which were present in parallel lines, in between parallel line. If this angle is 30 degree, this will be also 30 degree according to your corresponding angle theory, right? This is your corresponding angle theory. These things are quite needed in physics. This is your corresponding angle theory, okay? And obviously these two lines has to be in parallel. Another type of angle it was that, again, two parallel lines. It's this time it's going to create a Z shape, zigzag shape. For example, if this angle is 30, this angle is also 30. You can clearly see this one creates a Z shape, right? This is also known as alternate angle, alternate angles. Okay, alternate angles. Now this is the one that is being created over here. You can clearly see this one creates a Z over here. And the two corners of the Z are always going to create the same angle. Is there anyone still having any question how this angle is 30 degrees?
No.
Only these corresponding and alternate angles are needed. Other than that, there were some other angles also in maths, which was maybe interior angle and yeah, some of a triangle, sorry, some of a straight line, vertical opposite angle. Those are not needed. Okay. Now over here, we can clearly see that this tension is creating 30 degrees with the vertical plane. That means for the vertical plane, you're going to have the t cos 30, and for the horizontal plane, you're going to have the t sine 30 degree, right? We're going to divide two components. And now it says that the tension in the string or the pendulum is T, weight is W. Which statement is correct? You need to understand that which statement is correct. Obviously, this is wrong because H was in combination with sine, right? I can just resolve the equation separately. That resolving horizontally, that would be what? Resultant force equals to 0 because the object was stationary, right? At the end, there will be no acceleration. That's why the right-hand side, we're going to write the right-hand side as 0 from the very start because acceleration is 0. So now you have h minus t sine 30 degrees equals to 0. Eventually, which is going to be h equals to t sine 30 degrees. We're going to carry out the same working for the vertical forces again. So that resolving vertically, again, another thing, the object was in stationary for both the planes, in horizontal and in vertically. So resultant force is 0 in all planes. And now you have this t cos 30 degree minus w equals to 0. Finally, you can write w is equals to t cos 30 degree. That means t cos 30 degree was assigned with weight and t sin 30 degree was assigned with that h force. So this is not correct. This is again not correct because it was using components of that force, which was completely wrong, as H was only acting in the horizontal plane, so it will not be any component. This is the right one, and this is again right. So final answer over here is C. Final answer in this part. Is there any having any questions for explain some things that are not even needed because we are starting so a lengthy class. Okay, we will move on. And again, none of these were needed. Right? All of these useless. Use intercurrents. No workings are needed for these MCQs. Okay, it says that the diagrams represent systems of co-planar forces acting at a point. Planar means these are like free body force diagram, okay, where the only directions and the magnitude were represented using arrows, and the object is represented with a dot or circle. Right? This co-planar means this is a free body force diagram. The lengths of the forces which system of the forces equilibrium. Okay, now over here, in order to identify if an object will be in equilibrium or not, you have to find out the size of the angle, size of the forces, right? Which we can clearly see that if you're going to consider F1, F2, and F3, right? Over here, F3 is comparatively larger than F1 and F2. Let's just separately explain for all the four cases, like which one will be the proper correct answer over here. I know the answer would be B, but let's still explain that how I can find out the answer is B. I can only understand that F1 and F2 are of equal magnitude, and which means that I'm going to consider that as Y, okay? Which means that F3 is greater than that F1 and F2, right? It is greater than the combination of both. After this, I'm going to draw components over here. Now, without understanding or without having any values of angle, I can clearly understand. Let me just consider this as value for theta, which means that F2 will now be equal to what? F3 sine theta, and F1 will now be equal to F3. Sorry, that one would be F3 cos theta, right? Horizontal component. And this one will be F3 sine theta. Now again, if I try to find out their vertical forces or horizontal forces, I can clearly understand this F3 sine theta will always be greater than F1, right? Whatever the angle for theta is, component of that will not be extremely smaller. So I already know that F3 sine theta is greater than F1, which means that in the vertical plane there will be some extra force present because there is a resultant force greater in the downward direction, right? Since your downward F3 sine theta is greater than the upward F1. So I can write now that resultant force is in the downward direction. And if there is a resultant force, obviously there will be an acceleration. The object will move, right? And another thing, if 3 cos theta will again be greater than F2, which means that there's again a resultant force in the what is this, left direction, right? Which means there will be a motion overall. So obviously this is not a correct answer. Object will not be in equilibrium. Similarly, again, if I consider this is going to be F3, F2, and F1, we can clearly see that whatever the magnitude F1 or F2 was creating, they're equal with the vertical plane, right? And they also have the same magnitude because size of the arrows are of equal length. So we can now write again that F1, F2 is equal to Y, whereas similarly F3 is greater than Y. Again, their components would not be enough to be greater than that F3. F2 cos theta over here is going to be F1 cos theta.
01736 81638.
Is there any problem? I think someone was speaking. Sorry, I'm not with my laptop, so I cannot see the Google Meet screen. If there is any problem, please ask.
বেশ আরেকবার এক্সপ্লেন করবো?
হ্যাঁ, sure. আচ্ছা, এখানে mainly কি হচ্ছে that we're just trying to find out the components over here, right? we want to find out that if the three components or the three forces that are acting on the particle, which is present at the very center, are they going to be equal or not? That's what we're trying to find out. Okay. In order to find out that if the forces are in equilibrium or not, we need to find out, or we need to have this idea that all the forces at the end must be equal to each other, right? So in that case, ekhane, for this particular option C, we can now see that in this case, I'm trying to find out the components over here, where F1 was creating theta degree with the vertical. So the vertical component will be F2 cos theta. Over here, the magnitude of this F1 and F2 were of equal size. The size, the length of these two forces are of equal. In your question, it was already related that length of each force gives you the magnitude. That means if the length of these two forces are of equal size, that means obviously F1 and F2 are of equal length, right? Which means that F1 and F2 may be there of equal of Y. And F3 is completely a bigger force. We can consider this F3 at the end is going to be considered as a greater force compared to F1 and F2. Is this clear till now?
Yes, ma'am.
আচ্ছা এখন এটার পরে we are going to find out that components over here. Now in this situation we can see that obviously F2 will create a vertical component F2 cos theta, F1 again creating a vertical component F1 cos theta. Now again it was already stated that this angle and this angle is equal, as you can see from the figure, right? They are both inclined at the same level from the vertical plane. So the theta they are creating is also equal. If that means that if the theta is equal, forces are equal, it means these two vertical forces are entirely of same value. So if they are of same value, you can now write that for the resultant, for this vertically upward forces or vertical forces, you can now write that F1 cos theta, sorry, F1 cos theta is actually equal to F2 cos theta. And if they are equal, that means acceleration is going to be zero. Because they are equal, acting in opposite direction, they will certainly cancel each other out. So acceleration will be zero. That means the object C is in equilibrium in the vertical plane. Okay. Now, if the object C is in equilibrium in the vertical plane, another thing to focus on, for example, this line, if I take this line over here and place it in this part. Okay. As you can see that this length of that F1 was exactly what? Half of F3, right? You can clearly see on your diagram that this was the length of your F1, which we took from your original diagram, and this is half of F3, which means that if you're going to find out the component of F2 sine theta and F2 sine theta over here, they will be equal to F3, which is 2. I can consider that F1 and F2, they're both equal to Y units, right? Which means now I can write 2y sine theta. This time they are also equal to what? F3. If again in the horizontal plane the forces are equal, acceleration is again 0. So object C in the vertical and in the horizontal plane, in both plane, the object does not have any acceleration. In the vertical plane and in the horizontal plane, object's resultant force is 0. That's why there was no acceleration. If there is no acceleration, then what? Obviously, the object is now in equilibrium because in vertically, in horizontal plane, everything is equal, everything is balanced out. So obviously, they are now in an equilibrium state. Is this clear? And this won't be an equilibrium state. Why? Because, for example, all the forces are of equal length, right? We can clearly understand this is F1, F2, F3. All of them are in equal state. So what happens is that for that, if vertical forces, it's going to create F2 sine theta and then F1 sine theta as they were creating angle with the horizontal plane, which means now the horizontal planes will have that F1 cos theta is equals to F2 cos theta. Okay, now obviously in the horizontal planes they have equal forces. So acceleration is 0 in the horizontal forces, but in the vertical force, how much do you get? You get F1 sine theta plus F2 sine theta equals to as just F3. So if you're going to consider the value for F as maybe 3 newtons, okay, and theta as like 30 newtons, how much do you get? 3 sine 30 plus 3 sine 30 That is, you're getting 3. Oh, wait, 3 sine 30, 3 sine 30. No, wait. For part B, actually, the answer is going to be in equilibrium, right? Yeah. Let me just use these magnitudes over here. 1 minute. I actually don't have much space. 1 minute. I'll just open a different file and then we'll start, okay? This is a random file. I'll use it for that explanation. So in your part B, actually, that will be the correct answer. Over here, all the forces are of equal length, right? Hmm. So now I will make that plane again, horizontal and vertical. Now this is your 3 Newton. This is again 3 Newton, and this was again 3 Newton. Vertically downward was at F3, 3 Newton. This angle I'm considering as 30 degree and 30 degree. On the vertical plane, you're going to get 3 sine 30 degree and then 3 sine 30 degree, right? And on the horizontal plane, you're going to get 3 cos 30 and again 3 cos 30, which we can clearly see from the horizontal plane that yes, the forces are equal, right? On both sides, you have 3 cos 30. So if you're going to resolve horizontally, now we can write resultant force is equals to what? 3 cos 30 minus 3 cos 30, which is eventually going to be 0. So if resultant force is 0, acceleration is going to be 0, so object is in equilibrium in the horizontal plane. Similar processes, if you're going to resolve vertically, in that case, now you have this resultant force 3 sine, I mean, there are 2 3 sine 30, right? So I can just write 2 3 sine 30 degree is equal, sorry, minus 3. So now you have 3 sine 30 is, I think, 3 sine, sorry, sine 30 is 1.5 multiplied with 2 is 3. So this is again 3 minus 3, again 0. If resultant force is 0, acceleration is again 0. So for this diagram, the acceleration for the vertical plane and the horizontal plane, both was 0. If the acceleration is 0, that means object must be in equilibrium, right? All the forces are acting that are acting on the object are now balanced. That means option B will be your correct answer. This is how you actually identify. If there are 3 forces of equal magnitude acting on the plane, at the end, it is going to create the same, it is going to be in equilibrium for all the planes. Is this clear to you? Is there any problem till now?
No.
Okay, and let me explain that why C was not a correct answer, okay? I think for Arisha, you might not have understood the concept because you joined in the middle, but for Nusaiba, did you understood this part? Why this second option was a correct answer?
Yes, ma'am.
Okay, now let's do the same working for your option C. F1 and F2 are of equal length, whereas F3 was double than that. So this is your F1, this is your F2, and F3 was exactly double the length of this F1 and F2. So this is, and again, I'm going to draw the components at first, right? I'll obviously always draw the components at first. So now I'm considering again F1 and F2 as 3, which means F3 is going to be 6, right? This is your F3, 6 Newton. This is your F1, 3 Newton, and this is your F2, 3 Newton, okay? And we can clearly see again this theta that the F1 is creating with the vertical plane is equal to the theta F2 is creating with the vertical plane. So I'm going to consider these as 30, these as 30. I'm just using these magnitudes over here to explain you the idea properly. But obviously, by the time after some practicing, you can understand from the shape of the diagram that if the object will be in equilibrium or not. Okay, now in the vertical plane, you have three what cos theta, and in the vertical plane downward again you have 3 cos theta. For the horizontal plane, now you have 3 sine theta and 3 sine theta. Obviously, for that resolving vertically, resultant force this time is what? 3 cos 30 degree minus 3 cos 30 degree. That is 0, right? If resultant force is 0, acceleration is 0. So object is in equilibrium in the vertical plane. Okay, that is clear. But for the horizontal forces or horizontal plane, let's find out the resultant for this case. That is going to be 6 minus 3 sine 30, 3 sine 30. Now 3 sine 30 gives you 3 Newton, and 6 minus 3 is eventually 3 Newton. That means now for the horizontal plane, you have this extra 3 Newton force available in the horizontal plane acting in the right direction, right? Acting towards right. Because of this 3 Newton force, object must have a acceleration. So acceleration is present, which means that if there's an acceleration present, obviously object is not in equilibrium in the horizontal plane, right? It is in equilibrium for the vertical plane, but not in horizontal. So for vertical plane, equilibrium, but for horizontal plane, not in equilibrium, right? If I zoom out, is there any problem for this option B and C explanation?
No.
Nusaiba, I think this one was clear to Arisha also, right? Arisha, did you finish watching the 3 recordings of the previous classes we missed?
No, ma'am.
Why? The recordings are already uploaded, I think. Oh, sorry, I forgot. Sorry, no, you already gave me the reason. Sorry, no. Then I guess this class will not be that much helpful because you don't know the concepts, and we are using the question papers to, more have a better understanding. You can still be in the class, but this is actually the last lecture for vectors. That means you have to finish this entire thing by next week. Okay, Arisha, I'm speaking to you.
Okay, ma'am.
Okay, thank you. Nusaiba, is there any problem for options B and C so far?
No, ma'am.
Then as I've already stated, I'm going to extend the explanations a bit more. I'm going to explain again this option D in much detail now. Now again, option D, we can see that the 3 forces over here are not of equal length, right? So I'm going to consider one as 1 Newton, one as 2 Newton, and the other one, the largest one, as 3 Newton. Can you just wait 1 minute? Sorry, as I was saying, 1, 2, 3. There's a small force in this direction. In the horizontal direction, there's a moderate force. And again, in this third quadrant, you have a bigger force now. And again, we're going to draw the horizontal plane and the vertical plane. This is 1 Newton. This is 2 Newton, 3 Newton. Okay. Now, the angle F1 and this 3 Newton is creating is not equal over here. Let me see from the diagram again. Yeah. No, they are quite equal, right? 1 minute. Right, they are quite equal. Whatever the angle they're creating is quite equal. So we can consider again the same values. This is 30 degree, this is 30 degree, okay? obviously for this, obviously for this 2 Newton force, there is not going to be any components, right? Only that 1 Newton and 3 Newton will be distributed. So you have 1 cos 30, and then again you have 3 cos 30. You have 1 sine, 1 sine 30 degree. Okay, now after this, what I'm going to do is, where I'm going to find out the horizontal forces and the vertical forces, right? So resolving vertically, that will be what RF equals to 1 cos 30 minus 3 cos 30, which is 1 cos 30 minus 3 cos 30. That is negative root 3. Okay, whatever this is, the magnitude over here is not a matter. This means there was a resultant force of root 3 newtons in the downward direction, right? There is a resultant force in the downward direction. And we know that if an object is in equilibrium, there must be no resultant forces. For an object to be in equilibrium, the resultant forces should be zero. All the forces should balance each other out. So over here, it now has an acceleration, right? So obviously, object is not in equilibrium for the vertical plane. We're going to do the same calculation for the horizontal plane again. So resolving horizontally. Now you have resultant force 1 sine 30 degrees plus 3 sine 30 degrees minus 2, which is again going to be 1 sine 30 plus 3 sine 30 minus 2. This is in 0 Newton. Okay. Now, okay, the object is in, resultant force is now 0. All the forces are balanced in the horizontal plane. So acceleration is 0 for here. But again, the problem is that we want the object to be in equilibrium for all the planes. That means in horizontal and in vertical. It is in equilibrium for the horizontal plane, but not in the vertical plane, right? Over here, the object is in equilibrium, but on the vertical plane, it was not in equilibrium. If it is not in equilibrium, we cannot accept this as our answer, because in our answer, we want it to be in equilibrium in combination for the vertical and for the horizontal plane, right? So this is certainly not the answer. This was your explanation for part D, okay? Which means that over here, only object B is the correct answer. Option B is the correct answer because all the planes were balanced over here. Object was in equilibrium in horizontal and in vertical plane, right? Is there any question till now for this explanation?
No.
Nusaiba, for you, do you have any problem?
No, ma'am.
I'll just keep the explanations over here, okay? We'll move on to the other PDF. Okay. Now, question 2 is done. The answer is B, this one. Okay, so we'll move on to question 3. Question 3 is easy. It says that two forces of 10 act at point P as shown in the diagram. The angle between the two vectors are 120. Now, if it is 120, you have to find out the horizontal and vertical component. Now, obviously, this much is 90. Right, 120, you have to again use maths basics. This much is 90, right? And this portion is 30 degree. So in that case, resultant force, right? 10 cos 30 degree, two forces of this. And then again, for the horizontal component, you have 10 sine 30 degree. What is the magnitude of the resultant force? Okay. They wanted to find out the magnitude of the resultant force. Let's just find out for the vertical forces, only 10 cos 30 is acting, right? So 10 cos 30 is 8.7. Now you cannot see any option as 8.7, right? Over here, the resultant force will only be considered in the horizontal plane, because in the vertical plane, only that 10 cos 30 was acting. No other forces were acting in the vertical plane, right? So obviously, in the vertical plane, resultant force is going to be 10 cos 30. That is not a calculation over here. Over here, RF is just going to be 10 cos 30 degree, which is almost 8.7 Newton. Now for the horizontal forces resolving horizontally, now you have resultant force, what? 10 minus 10 sine 30. Sine 30 is half multiplied with 10 is 5, 10 minus 5 is 5 Newton, which means option A is your correct answer. Is it clear for all of you?
Yes, ma'am.
Wait, did Arisha left the class? Okay. Nusaiba, is this clear to you?
Yes, ma'am.
Okay. Now again, Nusaiba, I think your problem was about not solving enough question papers, right? So I think during our classes we'll solve more worksheets with time. So I think you can overcome that. Okay. There's nothing to worry about. I think from the last exam you got a little bit demotivated in physics because you were not able to understand the question pattern, right? Understanding the concept and appearing for questions are two different things. You need to solve these question papers as much as you can in order to do a good in exams. Okay, understanding the concepts is actually the easiest part. Solving this question paper is the tough part. Okay, for question 4, this is a little bit of a projectile motion. I know we haven't started this yet, but we can solve this using our vectors basic. Okay. Now, a projectile is fired at an angle alpha to the horizontal with a speed of u. Now, this is a velocity. Velocity is a vector quantity, right? And whenever vector quantities are acting on an object which is not entirely on vertical or horizontal, then components will be created. Right over here, they want you that what will be the vertical and horizontal components of its velocity at time t seconds. Assume that air resistance is negligible and acceleration is due to free fall. It indicates that what would be the final velocity in the horizontal component and in the vertical component. Okay. Now, as this is a part of projectile motion, I know we haven't started this, but I'll just give you one hint over here, right? As you can see, obviously the and the initial velocity will be divided into two portions, right? The vertical plane and the horizontal plane. I'll just draw it over here first. This is the vertical plane and this is your horizontal plane. There's one thing to remember, that in projectile motion, your object will actually travel two different journey in one time. The object will travel horizontal motion and in vertical motion. Okay. So in vertical motion, object accelerates at 9.81 meter per second square. Okay, and for this cause, we can use all the equations of motion for the vertical motion calculation. Okay, so all equations of motions are available. But for that horizontal motion, okay, in horizontal motion, there's not much space for it. I'll just write it down over here. In horizontal motion, object moves with constant velocity. Constant velocity. That means these equations of motion can never be used for that horizontal motion part of the projectile motion journey. Right? Only equation we can use is this constant velocity equation, which is v is equals to d over t. Another thing, this is a double motion case, right? For this scenario, projectile motion could also be in single motion. That is not a problem. But the specific example this question 4 is using is for a double motion, because you're going to project this object upward and it might fall back in the downward direction in the next sessions of its journey. Or whatever the case is, as the object is traveling in an upward direction against motion, g over here is going to be minus g, right? Because this is a motion against gravity. This is moving in the upward direction. In upward direction, what happens? All the vector quantities are positive except for acceleration. That's only because that in the upward direction, object actually decelerates, right? I think for Safia, we have did this kind of concepts a lot in equations of motion, that in upward direction, single motion, or in double direction, acceleration is negative, because in the upward direction, the velocity actually decreases. And if velocity decreases, object must be decelerating. So over here, the value for g is actually negative g, because this is a upward direction, right? Object is decelerating in the upward direction. Okay. Uh, we'll find out the horizontal component, which is going to be u cos alpha. Sorry. And this is going to be u sine alpha. Right? Vertical component is u sine alpha, and horizontal component is u cos alpha. Okay. Now after this, resultant force, sorry, not resultant force. I will try to find out the final velocity of the vertical component and horizontal component. For the horizontal component, object moves with constant velocity. That means along the entire journey, velocity will remain same, right? So there's no calculation need to be done. If the initial horizontal component, like the horizontal component of the initial velocity was, wait, what is this? Sorry guys, I think I will need to provide you another meet link. I'll send it to you after 5 minutes, right, after solving this question. Okay. As I was saying that in the horizontal component, object can only move with constant velocity. So if it is moving with constant velocity, velocity doesn't change for the entire journey. So if your horizontal component for the initial velocity was u cos alpha, that means the vertical component for the for that final velocity would still be u cos alpha, right? It doesn't change. So u cos alpha will be the correct answer. So u cos alpha. From this knowledge, I can understand that A and B out of these two will be the correct answer. If you want to find out the vertical component, now in vertical motion, object accelerates with a constant rate. So all the equations of motions are available now. So we have to find out the final value for V using these values that are provided. So for the vertical component, I know UV, initial vertical component velocity, is u sine alpha, right? Vertical component of the initial velocity is u sine alpha. Acceleration is going to be minus g, and time over here was for t seconds, right? It was stated somewhere in the question, right? T seconds. Time over here is t seconds. Okay. Now I can use that equation v is equals to u plus at, which is going to be u is u sine alpha, a is minus, so I can directly write gt, right, which you can clearly see option C is the correct answer. U sine alpha minus gt and u cos alpha. Is there any question till now for this question 4?
No, ma'am.
Okay, just 1 minute. Okay, now we will move on to the next question. Oh, sorry. Yeah, I mean, we can solve another question and then I'll give you the new meet link. Okay, now in question 5. This is about a car, right? A car with a front wheel accelerates in the same direction, in the direction shown, obviously towards what? Right? Which diagram best shows the direction of the total force exerted by the road on the front wheel? Can anyone explain me which one will be the correct answer over here? Nusaiba, you first. Try to explain which one will be the correct answer.
C.
Why do you think that the answer would be C? Any explanation why you think answer C is the correct answer? Wait 1 minute. Sorry. Yes. Why do you think answer C is the correct answer? Safia, do you have any idea which one would be the correct answer? C is the correct answer actually. But I think Nusaiba got stressed a little bit because the object is moving towards right. Right? That means the tires over here, sorry, not C is the correct answer. Car is moving towards right, but if you think of it, the tires are going to move in a clockwise direction, right? This is the direction the cars will move. That means the car will actually exert a force in this direction on the road, right? So if the car is providing a backward direction on the road, friction on the front wheel will actually be in this direction. According to your Newton's third law, every action has an equal and opposite reaction. Right? This is the force exerted by that car on the road, and with a response for that, road will also exert a exact amount of force, but in the front direction. Okay. I know this is a little bit about forces, but it was still kind of related to directions and vectors, so I decided to add this. So option D is your correct answer. Is there any problem for question 5?
No, ma'am.
Now, can anyone explain or give me a definition for friction? Just a random definition, whatever you have in mind. Just give me the definition. I think in IGCSEs we did learn some definitions in for frictions, right? Any definition? Musaiba, do you have any definitions in mind to define friction? তারও কিচ্ছু মনে নাই ফ্রিকশনের ব্যাপারে? আচ্ছা, ফ্রিকশন কি জিনিস? সাফিয়া, ফ্রিকশন কি?
It's the force which opposes the motion.
বুঝাই গেল না কি বললা। হুম।
It's like it provides resistance when like two objects. It's a resistive force.
Safia, 80% correct, right? যে if an object is moving, it will provide a resistance, right? It is basically আমি যেটা পড়ছি বা what I teach to my students in IGCSE is that um, it is a force that opposes motion, right? In whatever direction you're moving, it is always provide a force in the opposite direction, right? In whatever direction you're providing a force, it will provide an opposite force in to that direction. So basically in IGCSEs what we saw is that friction is a force in opposite direction. So sorry, is a force that opposes motion. I'm sorry, is a force that opposes motion. Now in A levels, with addition to this, we are also going to learn another new statement for friction, that it not only opposes motion, it will also cause motion. Okay, so it also causes motion. Now, from our basic understanding or from our basic knowledge, from our IGCSE knowledge, we were only drawing this like if a car is moving in this direction, in which direction friction must move in the opposite direction, right? Which was still correct, obviously correct, that in this, if the object is moving towards right, friction must be in the opposite direction, left. But now if you think about the tires basic, this is for the entire object, right? Friction air resistance is also considered as a type of friction, right? So in that basis, if you're moving towards right, air resistance will act in the left. That is considered as one of the part of his friction again. But now over here, what happens according to your tires, right? When you're moving in the front direction, tires don't move in this direction, right? Tires don't provide forces in this direction in the front. What tires do, tires move clockwise in a clockwise direction. And when tires are going to move in a clockwise direction, they're going to provide a force in the backward. And according to Newton's third law, because of this backward force, there will be like a force exerted by the surface on the tire in the front direction, right? This force was exerted on the road. This force is exerting on the car body. And because of this force is being exerted on the car body, car will now accelerate in this direction, the direction of the friction. Right? Is this clear? I mean, obviously, its main motive was to oppose motion, but you have to think about the directions of the tires, right? This is not a regular object. This is not any, square rectangle object. This is a circular object. If this was a case that moving forward, our tires would move in an anti-clockwise direction, then the force exerted by the tire on the road would have also been in the forward direction. In that case, friction would have been in the backward direction, but that would only make your car move in the backward direction. Over here, your car can move in the front direction because your tires are moving in clockwise direction. While moving in clockwise direction, they're going to provide a force in the backward direction. This force over here is exerted on road, right? This is not related to the tire anymore. Like this is exerting, right? It is not and the car will not experience this force. This force was exerted on the road. So this was entirely eliminated from the car. But with response to this force, the road will also provide a force of F newtons on the car, right? Now, if you think of it, there are no other forces acting on the car. Only this friction will now act on the car. So certainly because of this friction, there is now a resultant force and object will now move in the forward direction. That's why option D is the correct answer. Is this clear?
Yes, ma'am.
Okay, and again, I'll obviously write down the entire explanations when we're going to start with forces chapter after we're done with projectile motions. Okay, this is entirely for that friction force concept. Friction force concept. I'll just write it down over here so that we can revise it when we're going to do that friction force concept. Okay, but otherwise this is the main base idea, that why force like friction is state considered to have, it also causes motion, why it can start motion. For example, why you cannot walk on slippery surfaces, because friction is not there, and because the absence of friction, you cannot move forward. So friction is required for this extra force to be exerted on the object to make it move in the forward direction. So friction always is in the direction of motion. Okay. Now over here, this is quite easy. A balloon is acted upon by three forces: weight, upthrust, and sideway force due to the wind, as shown. Which of the what is the vertical component of the resultant force? I mean, what vertical component will be the subtraction of these? Because over here the forces are in opposite direction. They will certainly be subtracted from each other. That is 1000. Option B is the correct answer, because in the upward direction you have 10,000 minus 9,000. Yeah, then you have just 1000 left. Right? This is resultant force in the vertical direction. This is only working. I hope this was quite easy. Not anything brainstorming related to this. Similar to this one, it says that a magnitude of 5 to be represented by two perpendicular components OY, OX, and they have already given you the perpendicular force, okay? And they want you to find out what will be there on the horizontal component. In that case, you have to think of it like this. This is theta. If this is theta, then this one must be 5 cos theta, which value is already given. So we can write 5 cos theta is equals to 3. Okay, I just want to find out the theta from this equation. That is it. In that case, cos theta is going to be 3 over 5, and theta would be cos inverse 3 over 5. Now I can clearly understand this is an acute angle, right? Safia, can you explain what does acute mean? Acute means less than 90 degree, right? So we can clearly understand this is an acute angle. So cos inverse 3 by 5 is 53.1 degree, which is again less than 90 degree, so which is fine. Which means that this horizontal component OX was 5 sine theta, which is going to be 5 sine 53.1 degree. That is 3.998, which is almost 4, right? 3.998. According to one decimal place, you're going to get 4 over here. So 4 is the correct answer. Is this clear?
Can you explain once again?
I can, but I'll give you a. Okay, now the question I was explaining, it was like, partially maths, partially physics. For example, this concept I was trying to explain is that the angle over here was missing. Okay, so if your angle is missing and the vertical component is 3 Newton, how would you break down this 5 Newton? Obviously, it will be broken into two components. The vertical one will be 5 cos theta and horizontal will be 5 sine theta. I already know the value for this vertical component, which is 3 Newtons. So I can write 5 cos theta equals to 3. 5 is taken to the left hand side, sorry, right hand side. Cos in the right hand side will be cos inverse. If you take this entirely on a calculator, this is the value you get, right? Now using this value, the theta is now calculated, right? What would be the horizontal component? 5 sine theta. Theta is 53.1. You get 3.998, approximately 4. Is this clear now?
Yes, ma'am.
And if this is not clear, this is entirely a mathematical way using cos and all these things. If this is a little bit trickier for you, you can also do one thing. You can, rearrange the forces over here. Originally, the forces were like this, right? What you can do is that you can just take this vertical force from this part and connect it over here, right? I think we did this kind of calculations in our classes also to make it a triangle rule. After it is a triangle rule, we can clearly understand this is 90 degree. And horizontal forces was OX, vertical force was OY, which is 3, and the actual vector over here was 5 Newton. So we can clearly understand in that case OX is going to be 5 square minus 3 square, entire thing under a root, and that will give you a solid 4 Newton. Right? Using the triangle method, you can also solve this. In your physics, actually, if I consider, this is a better option, right? Because in physics, we only learn about the triangle and parallelogram method. This cos theta, this is also acceptable, but not that much acceptable in mark schemes, I think. Now, I haven't seen the mark scheme for this question, but this must be not there. From my basic, this is much more acceptable process than this. But otherwise, both might be accepted actually, because at the end of the day, these are maths. Maths can be solved in multiple ways, so no problem with that. Okay, is this clear to you? Question 7.
Yes, ma'am.
This is more preferred, and the other one was less preferred. Okay. Okay. Question 9 is halfway here. The answers are on the other page. Now over here you have this. The diagram shows a sign of weight 20 Newton suspended from a pole, attached to a wall, and the pole is kept in equilibrium by a wire attached at point X of the pole. Okay. If you have a wire, that means obviously there will be some tension. The force exerted by the pole at point X is F, and the tension in the wire is 40 Newton. On the which diagram represents the three forces acting on point X? Okay, three forces. Hmm, 1 minute. What is 20 Newton over here? A diagram shows a sign of weight. So weight is 20 Newton, and the force exerted by the pole at point X. Okay. 1 minute. You have to first identify the forces that are acting on this. The weight of the sign was 20 Newton, right? Which means that from here, there will be a vertical force of 20 Newton in this direction. The tension on the wire was 40 Newtons. So along this inclined plane, you have this 40 Newton force. Okay. The most difficult part over here is to identify the direction of that F Newtons. Focus very clearly on this. Force exerted by the pole at point X is F. Now, this is your pole and this is your point X, right? Over here, the point X will experience a force in horizontal direction. This is the direction of your F. Now, how can I understand that? Because over here, the pole will try to move this point in this direction, right? Otherwise, what happens is that the sign over here, the weight of the sign will make the pole move in an anti-clockwise direction, right? Because this is a pole, movement will act actually over here. The pole was actually originally in this direction. Because of the force, it would be moving in a clockwise direction about the point wall. But that will not occur because all the forces are balanced and because this F Newton is going to be exerted by the pole on point X in this direction. Is this diagram clear? The distribution of the forces over here.
Yes, ma'am.
Now I'm going to draw a triangle method, right? As I've already stated that for two forces acting on a plane, we're going to use parallelogram method. For three forces acting on a point, we're going to use triangle method. I'll first obviously draw the vertical 20 Newton force. 20 Newton force, then F Newton force, and that, and that inclined 40 Newton force. This is a complete triangle, 40, 20, F. If I try to manage this and match this with any of the answers, this is option B, right? 20, F, and 40. So option B is the correct answer. Right, option B is the correct answer. Is question 8 clear to you?
Yes, ma'am.
Okay, then we will move on. Question 9. Which two vector diagrams represent forces in equilibrium? 1 minute. Which two vector diagrams? Like two of the diagrams over here is going to represent the two forces are in equilibrium. Okay. One minute. In triangle method, two vector diagrams represent forces in equilibrium, right? Let's break down the forces to their original format. For example, this point P, we have a vertical force and wait, no, we have a horizontal force in this direction, another force, and in this direction, another force, right? Yeah. So P over here, the forces, we use the force vector diagrams represent the forces are in equilibrium. Now, I think you have to understand from that, like, angle in between them or size over here. Okay. Hmm. They are not of equal length. For Q also, they are not of equal length. They are perpendicular, so they would have some forces left. So Q and R, they are perpendicular forces, right? We can see from the diagram. This is 90 degree, this is 90 degree. V1, V2, V1, V2. You know, you have to think of it this that whenever you're going to create a perpendicular triangle, right, that will be your correct answer over here. So, for example, always remember that in perpendicular triangle, what happens? We can use Pythagoras theorem, right? So, Pythagoras theorem actually explains that when you consider this as A, B, C, it actually says that square of A plus square of B is actually equals to square of C. That means the left hand side is equal to the right hand side, which means obviously the object, if I want to find out the resultant force over here, it is going to be A plus B minus C, and then you're going to get 0, right? Because they are both equal. A plus B, like the summation of A plus B is equal to C, which means whatever the magnitude you get for the summation of AP, that is equal to C. And if you subtract it, you'll get zero force. So you have to find out that out of these 4 diagrams, which one is a right angle triangle. Can you find out which one is a right angle triangle?
Ma'am, R.
I mean, can you find out that out of these 4 diagrams, which ones are right angle triangle? Because whenever the forces are going to create a right angle triangle shape, they're going to be in equilibrium. So which ones are in right angle triangle?
Ma'am, is it R and Q?
Right, R and Q, because obviously these are not right angle triangle, right? In any way, even if I highlight this, right, from this plane and this plane, this is less than 90 degree. This is a scalene triangle. From this one and this one, similarly scalene triangle. But if you focus on this one and this one, this is what, 90 degrees. This one and this one, 90 degrees. So obviously R and Q, which means option B is your correct answer. Q and R, right? Q and R. Q and R is your correct answer. Is this clear?
Yes, ma'am.
So whenever you're going to get these concepts that random diagrams of triangle, and you want to find out that which object is in equilibrium, you try to look out for right angled triangle, right? Which is going to be, then we can use Pythagoras. I'll just write it down over here. Okay. So Q and R. Okay, we'll move on to this question. A length of string is attached between 2 vertical posts. A bar of weight W stands on the middle of the string, causing tension T in the string. The string makes an angle of 80 degrees with each post as shown. Which of the following expressions is correct? Okay. I have to find out the distributions over here, right? We want to find out the value for tension, but that can only be found out if we can create the vertical component and horizontal component. Now the weight was given, the weight was not given, so that's not a problem because on your answers also, they're also in terms of weight, right? So there's not a problem. We'll first find out the vertical and horizontal components. This is actually taken from your M1 question paper. Okay, like M1 and physics unit 1, they have a lot of things in common. So you have this weight. Again, what? If this tension was creating vertical with 80 degree with the vertical component, over here is going to be 80, and over here it's also going to be 80, right? In that case, now you have horizontal component as T sine 80 degree, and again at T sine 80 degree. For the vertical component, now you have T cos 80 degree, and again from there you have T cos 80 degree. So obviously for the horizontal plane, that is a dead end, right? Because on both sides you have T cos the 80, and they're in opposite direction. So it just indicates that in horizontal direction, resultant force is 0 since T sine 80 is equals to T sine 80, right? And over from this part, you actually do not get any value for T. You have to focus on the vertical plane. In the vertical plane, resolving vertically, now you have RF is equals to, I already know this object was in equilibrium, right? I think it was stated somewhere. 1 minute. Yeah, I mean, this is an equilibrium. Okay, the object is not moving in any direction. It was not stated, but we need to understand that. Resultant force is equals to 0. Now I know you're going to get what? In the upward direction, you have this 2t cos 80, right? Because t cos 80 plus t cos 80, you're going to get 2t cos 80. So 2t cos 80 degree minus weight is equals to 0. I'll just take that weight to the other hand side. So 2t cos 80 is equals to weight, and I'll just keep the t over here and 2 cos 80 on the right hand side, so it becomes w 2 cos 80. So C is the correct answer, right? 2w t cos 80, right? C is the correct answer over here. Is this clear to you now?
Yes, ma'am.
Okay. I think Arisha and Nusaiba left the class because they were not understanding the concept, since both of them quite missed most of the classes for vectors, right? But I think for you, who actually attended all the classes, solving this question paper, is this clearing your concept about vectors a little bit?
Yes, ma'am.
Right. I mean, in our lecture classes, we understood the concept, and over here we're applying the concepts, right? Okay, so I'm going to stop the class over here, and we only could solve question 10 up to question